Simplifying square roots, okay, radicals, square roots, whatever you want to call them. We have square root of 1053. Now, question is 1053, is that rational or irrational? Well, my square root list doesn't really go that high, so I'll just square root it on the calculator, and that looks like it's irrational to me. So put the IRR label, and you need to start dividing. So 1053, we would first divide it by 400. Doesn't appear that that works. Divide by 361, that's not going to work. Divided by 324, that doesn't work, it's 3.25. Divided by 289, nope. Divided by 256, nope. Oops, I did 2053. So 225, nope. 196, nope. 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 Okay, 81 works. Okay. So we split that into the square root of 81 times the square root of 13. So then the square root of 81 is equal to 9, so this is replaced with 9, and it's 9 times the square root of 13, 9 square root of 13. Now the square root of 70, well, 70 is definitely not a perfect square, so that's another irrational square root. So I divide, so I'd take 70 divided by 64, and that's not working. 70 divided by 49, that's not working. 36, that's not working. 25, that's not working. 16, that's not working. 9, nope, that's not working. 4, nope. And then that takes you to 1. So when it takes you to 1, you just circle the square root of 70, because you could divide 70 by 1, but you just get the same thing. Okay. Now, this one's an easy one, the square root of 100. Well, that's a perfect square, so it's a rational square root. It equals 10. Okay, so I just put 10. There's your answer. Okay, now we get some more complicated expressions to simplify involving square roots. We have the square root of 75 times the square root of x to the 5th times y to the 6th. So when I have this one square root and I have 3 different factors in the square root that are unable to be multiplied, we need to split the square root into the 3 factors. The square root of 75, the square root of x to the power of 5, and the square root of y to the power of 6. So 75 I simplified just like I did on the front side, so it's not a perfect square, it's irrational. Okay, so I divide. Now I divide 75 by 64, that's not working. Then by 49, that's not appearing to work. 36, nope. And then 25, yes. Okay. So I'd put that as a square root of 25 times the square root of 3. And the square root of 25 is equal to 5, so we have 5 square root 3. Now, and you're going to have a square root with a 5 out and a 3 in. Okay, now the square root of x to the 5th. Now remember, x is an unknown value, but it's to the 5th power, which would mean there's 5 factors of the x variable. Now we break up the square root further so it covers 2 x's at a time. And this x here at the end just will have its square root. Now the reason we do 2 at a time is because x times x is x to the 2nd. But the square root and the 2nd power cancel, and it gives me a full factor of x. And then the same thing happens with this square root of x times x. It's x to the 2nd. Then the square root and the second power cancel, giving me x. Now this x here stays in the square root. You don't get a full factor of x there because you don't have the second power with the x, so the square root stays. So there's two full factors of x, and then a square root of x. Okay, so we're going to have an x second out and an x in. Okay, now y to the sixth power. That would be, y is an unknown value, it's a variable. It would be 3, 4, 6, or excuse me, 6 factors of y. And we do the same thing, we put the square root over 2 of them at one time. Because y times y is y second, but then the square root and the second cancel, giving me the full factor of y. Y second, cancel, gives me the full factor of y. And then y second, but the square root over it cancels it, and it's y. So that's 3 full factors of y. And we don't have a square root, so this y to the third, this whole thing comes out. Okay, y third is out. So 5x second, y to the third times 3x. Okay, now in this one we have 3 times the square root of 5 times 4 times the square root of 15. So it's all multiplication. If I have two different square roots and it's multiplication, which that is, set it up into 3 steps. Okay. Step 1, you multiply the outside coefficients, which would be the 3 and the 4. And on that same step, you multiply your square roots. Okay. So 3 times 4 is 12, and then the square root of 5 times the square root of 15 is the square root of 75. Now, step 2, you need to simplify your new square root. So I drop the 12 down, that's going nowhere. Then I write times, and then I simplify the square root of 75. Now, 75 is not a perfect square, so it's irrational. So we put divided by, and then I start dividing 75 by the perfect square value. 75 divided by 64 decimal. 49 is a decimal. 36 is a decimal. Okay, 25 and 3. So we rewrite that into 2 square roots, and 25 and 3. So the square root of 25 is replaced with 5. And then instead of the square root of 75, we replace it with 5 square root of 3. And then of course the third and final step is just to simplify the outer coefficient. Okay, so 12 times 5 is 60, and then it's still multiplied by the square root of 3. You can't multiply anymore. Now, 8 times the square root of 48 plus 7 times the square root of 75. Well, that's a times. Now it's a plus. So plus, you got to get these to be like terms. That's how you add in algebra. Okay, so you're going to make a table, and on one side you're going to put 8 times the square root of 48, and on the other side 7 times the square root of 75. Because see, we can't add anything yet, because the 8 and the 7 are your coefficients, but the square root of 48 and the coefficients aren't multiplied by the same thing. We're trying to simplify these so the square roots would match and be the same. So we drop the 8 down, and the square root of 48, not a perfect square, okay? So it's irrational, and then divided by square root, square root. Hopefully I can find something to divide it by. So 48 divided by 36, decimal. 25 is a decimal. 16. Now that's the one I want to use. Now this also is divisible by 4 and you get 12, but you want to do the highest possible perfect square to make sure it's simplified correctly. So 16, 3. So the square root of 16 turns into 4. So instead of the square root of 48, we put 4 square root 3. And then we take 8 times 4, which is 32 square root 3. So we replace this with 32 times the square root of 3 plus. Now 7 times the square root of 75. Square root of 75 is irrational. 7 times, and then we divide into the 75. So we'd start by 64 decimal, 49 is a decimal, 36 a decimal, 25, okay, so 25 and 3, so I rewrite this into the square root of 25 times the square root of 3. So the square root of 25 changes into 5, and now that's 7 times 5 times the square root of 3. So 7 times 5 then is 35 times the square root of 3. Now we have two new coefficients with the 32 and the 35, and since they're multiplied by the same thing, we can write square root of 3 and then add 32 and 35. That's going to be 67. 67 times the square root of 3. Okay, now we're going to get some 90-degree triangles. Okay, find the values for x and y. Now, I'll be finding x here and y here. Now, to find these, you know you're going to need to use proportions. You know this because you only know one of the sides. Anytime you only know one side, you got to find the other two. You want to use proportions, and so you can cross multiply and dividing. But we're not using the sine, cosine, tangent here because it's a special right triangle. Because 60, 30, 90 is a special right triangle. So I know that those form the ratio 1, 2, and the square root of 3. So you put 30 degrees, 60, and 90. So across from your 30 is 1. Across from your 60 is the square root of 3. And across from your 90 is 2. Now put those in parentheses with the actual side values. So I go across from my 30 and 1. I go across from the 60 and then the square root of 3. Then I go across from the 90 and I've got 2. Okay, so we have that. Now time to solve for x. So x, put the actual side x with its ratio value 2. And then down here on the y, put the y with its ratio value of the square root of 3. Now both of those are teamed up with the 7 and the 1. Make sure, again, make sure x is over 2, so the 7's got to be over the 1. Okay? That'll be the same thing here. Now I'm going to find what x is. Okay, so it's 2 times 7 divided by 1. That's easy. It's 14. 14 divided by 1 is 14. So x is 14. And that makes sense, again, because if 2 is twice the amount 1 is, so 14 would be twice the amount 7 is. And that's how that works. Okay. Now y equals. So we take 7 times the square root of 3. You want to write the full number first, followed by the square root, because you know you can't multiply those. Okay. You could here because you didn't have a square root, divided by 1. Now, 7 divided by 1 is 7, so it's 7 times the square root of 3. You divide those two. 7 square root 3. So that was an easy one. It's not one of those pain in the butts where the square root ends up on the bottom. Remember, we got to fix that if it happens, but it didn't. Okay, and then this is another one. We have to solve for x and we have to solve for y. Okay. Well, there's two unknown sides, so that right there is proportions. But we don't go to the sine, cosine, tangent, because 45, 45, 90 is also a special right triangle. Okay, just like 30, 60, 90, where the sides form ratios. So 45, 45, 90. So opposite your 45s are 1, each one. Okay. Then opposite the 90 is the square root of 2. When I write equals, I'm meaning what's the side straight across from it. So if you go to 45, put 1, 1, and go across your 90, you put the square root of 2. Okay. Alright, so we're going to put x over 1, and we're going to put y over 1, and then we're going to put 6 over the square root of 2. Both these. Okay, now this is going to be a little dicier. we're going to take 1 times 6 and then divide by the square root of 2. But you can't divide by a square root. So we know 1 times 6 is 6. So if I have to divide by a square root, I don't want that. So I need to multiply both the top and the bottom by the square root of 2. So I know I can't, 6 square, that'll just be 6 square root of 2 on top. But the square root of 2 times the square root of 2 is 2. It's 2 without the square root. It's like the square roots just can't. It's like this is the square root of 4, but the square root of 4 is 2 whole. Now you can divide. So 6 divided by 2 is 3. You divide these two, and then the square root of 2. Okay, that's your x. And then the y is going to be exactly the same. Okay, 1 times 6 divided by the square root of 2. Now, you can multiply 1 by 6. You just can't divide 6 by the square root of 2. So, you extend the line, you multiply the top and the bottom by the square root of 2. Because that's 6 square root 2. And this is just 2. Okay? And 6 divided by 2 is 3 square root of 2. Okay, so x and y are the same thing. Okay, find the 3 trig ratios, sine, cosine, and tangent. Well, you're obviously going to need your SOHCAHTOA up here. Okay, so sine, cosine, tangent. So sine is O over H, A over H, O over A. Now, what do we know so far? Well, we don't know the H. Opposite the 90 degrees is always the hypotenuse, the H, the hypotenuse. Now, for O and A, you got to know where your reference point is at, if I can spell it right. Reference point's the theta sign, so O is 10, so we know O is 10, and then the A is 6. So I know 2 sides. I don't need to use proportions, okay, because there's only one side I don't know. So let's fill in what we do know. O over H, so that's going to be 10 over something. We will have to find the H. Cosine's A over H, so that's going to be 6 over something. We'll have to find the H. This is O over A, so 10 over 6. So we have the tangent done. Now, when there's only one unknown side, you don't use the proportions. You want to use the Pythagorean theorem. Which is a squared plus o squared equals h squared. Okay? So a we have is 6. O we have is 10. H is what we don't know. Okay? So 6 to the second, 6 times 6 is 36. 10 to the second, 10 times 10 is 100. Then h to the second. Now you're using linear properties to solve for h. Well, you don't have to add or subtract anything off the side of the h to the second, because that's already by itself. We do need to add these, so I have a number over there that I can find the square root of. So 36 plus 100 is 136, and then I find the square root of 136. Okay, and unfortunately for us, 136 is not a perfect square. Okay, so it's irrational. So you need to start dividing. Okay, by 121. Nope. 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 Okay, 4 and 34. So that'd be the square root of 4 times the square root of 34, and of course the square root of 4 turns into 2. So h is equal to 2 times the square root of 34, and that's your hypotenuse. Okay. On these, I don't care if the square root's on the bottom. Don't worry about that. And there's your ratios. Okay, those are your answers. Okay, now you're finding the 3 sides and the 3 angle measurements of the triangle. Now the sides are easy, or the angles are easy. It's the sides. So what's OA and H? Okay, well, First off, you know you're going to need the SOHCAHTOA because it's not a special triangle, it's a random triangle. That means it's not 30, 60, 90, it's not 45, 45, 90, so you're going to need to do the SOHCAHTOA and have that there, or this gets very nasty. Sine, cosine, tangent. Okay, so H, I don't know H, okay, that's one of the things sides I don't know. Now the reference, there's no theta symbol, no, you don't just put one in. Your reference is going to be an actual degree amount of 34, okay? So O, I don't know the O. I know my A is 7, so I have one side, but I have two unknown. When there's two unknowns, you got to use the ratios to find those, okay? So I'm going to find A here, and I'm going to find H here. Of course, or excuse me, O here. I need O. O and H. Okay, now I need to have A in both the proportions because A is where I actually have the value. So we need to put that reference degrees in the proportion over 1. Now O and A is tangent, so it'd be tan. And that's O over A. Okay, so O is unknown, A is 7. So to find the O, we take tan 34 times 7 divided by 1. And I got 4.72. So that's how long side O is, approximately. It's irrational, but that's okay. H and A is the cosine, okay? But that's A over H. That's why you have that written up there, so you have it. A over H. Okay? So, A again is 7. It's the H we're trying to figure out. So I take 1 times 7 divided by cos 34. Okay, 8.44. Remember, 8 should be the longest side, and it is. If it's not the longest side, something's wrong. Okay, now the degrees. Well, you got 34 degrees, 90 degrees, and then 180 minus 90 minus 34 gives you the other one. So that's going to be 56 degrees. Okay, then our last problem in this vlog, we've got, we have to find the area of this. It's a regular pentagon, okay, 5 sides is a pentagon, okay. So finding the area of any regular polygon is S times N times A divided by 2, okay. This is put area there. Okay, so S is the side length 16, okay. N is a number of sides. Well, there's 5 sides. Count them just to be sure. 1, 2, 3, 4, 5. Okay, that's easy. Now A is that nasty apothem. Okay, that's where you have to go to the very center, draw a line that makes a right angle, and then make that into a triangle. Now, what's half of 16? The whole side's 16. I just made it into half. I just split that side in half. What's half of 16? If you don't know, you better divide 16 by 2. It's 8. Okay? Put the 8 down there. Okay? Now, a couple other things. We also need the degree measurement up there because we need to use the tangent. Okay? So, because we need degrees in this. So you take 360 divided by n. Well, what's n? Well, n's 5. Again, don't draw this. I'm just showing you. Don't make what I'm doing right now. Again, 360 divided by 5 tells you how many degrees would be in that angle there. But, well, it's split in half, so then you have to divide it by 2. So it's 360 divided by 5 divided by 2. It's 36 degrees. I'll take that right triangle down here, and so we can just focus on that and don't have to look at anything else. So, this is what you're trying to find, the apothem. Okay? apothem. 90 degrees, 36 degrees, and you've got 8. Okay, time to find the apothem. Well, I have to use the SOHCAHTOA, the proportions, okay? So, H, I don't even care about H, but I'll label it, okay? Reference. The reference is 36 degrees. If you have degrees, you reference that. So O is 8, so we have the O value, and then the apothem is my A value. The apothem is what you need to find, so put what you're finding, put a backslash, and then put the side where you have a number for it. Not H, it'd be O, okay? So I put that reference angle, 36 degrees there. Okay, so A and O. What's A and O? Well, A and O is tangent. And tangent's O over the A. We always use tangent for this particular problem. Okay, so I'm solving for the A. That's what I want to know. O is replaced with its value of 8. Okay, and then I will find A. So I will cross multiply 1 times 8 divided by the tangent of 36. So 1 times 8 divided by tan 36 gives me 11.01. And that's your A. Now you can solve the problem. 16 times 5 times 11.01, click equals, then divide that by 2. 440.4. And this would be square units, so units to the second power. I didn't give you feet or inches. That's your answer.